Hello, I'm Shannon Seaver. Today we're going to be talking about annuities. Specifically, our agenda is to determine the value of an annuity and to determine whether determine regular annuity payments needed to achieve a financial goal. And so what do we mean by what exactly is annuity before we go further? An annuity can be something that we use for retirement, like something that we take out of our paycheck each month to put towards retirement. A stock or bond, something of that nature would be considered an annuity, something that we continue to put in money during so many different pay periods. So what is the value and how do we find it? So if you deposit P dollars at the end of each year for an annuity that pays an annual interest rate R in decimal form, compounded once a year, this is your formula. So A is the future amount, P is the present amount, the deposit that you're making. So let's look at what this is in action. Okay, so we have $4,000 at the end of each year at 6.5% compounded annually for 40 years. So in this example, we're going to use the formula I gave you in the last slide and just plug these in the appropriate places. So we have 4,000 times 1 plus 0.065 to the 40th power minus 1, and then divide that by 0.065. And normally in PEMDAS you want to work from the inside out. So we're going to look at the inside of this. If you add that together, that would be 1 plus 0.065, so it's 1.065 to the 40th power, and then you subtract 1 from that. You would get 4,000 times 11.416 divided by 0.065. And now if you take all this into your calculator, your final answer would be $702,527.66. So that is how much you would earn after 40 years, or how much would be in your account if you put $4,000 into that account every year at this interest rate. So it's a nice pretty penny there. So now I want you to pause and try this on your own. First find the annuity like we did in the last slide, and then find out how much total that you earned after putting all that into your account. Okay, so then we'll have 1,000 times 0.2597 divided by 0.08. And then if you put that in your calculator, you get $3,246.04. So, you know, to find the interest on this one, you got to think about how much money did I put in. If you are depositing it once a year for 3 years, you put a total of 3 times $1,000 in it. So that would be 3,000 total. And we wanted to find out how much interest we actually got paid. Well, we're going to take what we found here, the total in our account at the end of 3 years, and subtract how much we actually put into the account. So this would be 3246.4 minus 3,000. So we'd have a total of $246.40 that was paid to us as interest. So remember, we're going to take the value of the annuity that we just found and then subtract the total payments. To find our amount of interest in that. Okay, so not all accounts have only one compounding time a year. Most of them have more than one. And so when that's the case, really the only difference is now we add this end value here in those 3 places into the same formula. So we will use that same formula. It's very similar to what we had before when we were doing compound interest. It does the same type of thing. So let's go to the next page here and practice that one. Okay, so we have $100 that we're depositing at the end of every 6 months with a rate of 4.5% compounded semi-annually for 25 years. So we're going to put 100 for P, and that'll be 1 minus the rate, which is 0.045 in decimal form, divided by N. Now, we know that's compounded every 6 months, so it's really twice a year. So I'm going to put 2 for my compounding. It'll be 2 times 25 for the exponent there, minus 1. And then that's going to be divided by 0.045 divided by 2. Okay, so if we simplify this, excuse me, it'll be 2.042 on the inside of the brackets divided by 0.0225, and then simplifying that further, that's $9,075.56. So we will have a total in our account of $9,075.56. So now I want you to try it again, and again, find the interest the same way we did it in the last you try example, where you take the total amount of payments that you put in and then subtract that from the total amount that's in the account. Okay, so on this one, if you put it all into your calculator, after you've set it up correctly, you would get $604,764.43. And when you want to find the interest, you got to first find the total amount of payments. You made $200 payments 12 times a year, 40 years. So that'd be $96,000. And then you would subtract that $96,000 from the amount that's in your account at the end of that 40 years. And you would get $508,764.43. So that is a lot of money that was paid to you through interest. Okay, so I have one more example to show you, and in this time we know what the total is that we want to achieve, but we don't know what the payment should be in order to achieve it. So we're going to use the same formula but kind of work our way backwards. How much should you deposit at the end of each month into an IRA that pays 6.5 compounded monthly to have $3 million when you retire in 45 years? Okay, how much of the $3 million comes from interest? So first of all, let's go ahead and find we know that A in this case is $3 million. Okay, we do not know what our P value is, so I'm going to leave it as P. So it's going to be 1 plus 0.065 divided by, and it's compounded monthly, so it'll be 12, to the 12 times 45 minus 1. So that's the top. The bottom will be 0.065 divided by 2. So we're going to have to do a little bit of algebra to solve this one. And by the way, this should be a 12, not 2, because that's how many times we're compounding it. So we want to simplify this down first to make it a little easier. And I'm just going to rewrite some of this out. This will be 3 million still on this side, 6 zeros. And P, and that is going to be times 1.0054 to the 480th minus 1 all over 0.0054. And if we continue to simplify this out, we will end up with P times 12.37 on this side. Well, actually, let's go back. It's not quite that. Yeah, divided by 0.0054. Okay, so we have 3 million equals this, and now we want to get P by itself. So I'm going to multiply both sides by 0.0054. And when I do that, I get 16,200 on this side. And on the right, I still have P times 12.37. And I still need to get P by itself, so I'm going to divide both sides by 12.37. So when I do that, I get 1,309 $1,012.62. And that's how much we would be paying per month for 45 years in order to get $3 million when I retire 45 years from now. Although if that was me, I'm not going to actually be that. I won't probably be alive by then. It's a long ways away. All right, so I'm going to give you guys a chance to try it on your own and then come back and check your work. Okay, so on this first one, if you plug it in and solve for P, you should get $186.57. That would be the monthly payment for 18 years. And if you wanted to find out what your total interest, how much you actually earned on this account, if you find your total amount of payments, that was at 186.57 times 12 times a year times 18 years, your total amount that you personally paid in was $40,298.51. And if you subtract that away from $100,000, you end up with $59,701.49. That was the total interest paid to you through the bank. So if you have any questions on this video, please bring them to class tomorrow.